In this video, we would like to introduce our smart system which can detect cyberattacks using AI technology for blockchain networks. This system is developed under the cooperation between the University of Engineering and Technology, Vietnam National University, Hanoi and the University of Technology Sydney, Australia. This system is part of a project named Cyberattack Detection and Information Security for Industry 4.0, which is sponsored by the ASEAN EVO, ICT Virtual Organization of ASEAN Institutes and the National Institute of Information and Communications Technology, Japan. The first blockchain network, Bitcoin, was introduced in 2008 to be a safe and secure decentralized form of payment. Today, blockchain technology has been advanced tremendously, and widely applied to various sectors such as medical, manufacturing, and IoT technologies. However, there have been many instances of attack on blockchain networks. This causes serious financial loss and damage in the stability of the systems. Motivated by this challenge, we have developed a smart model to detect cyberattacks using AI technology for blockchain networks. In this model, the data collected from various sensors such as temperature, humidity, light, and fire alarm are transmitted to IoT gateways by many industrial communication standards. The data are packed into transactions for blockchain networks at the IoT gateways. Our model uses an efficient deep learning technique to analyze the transactions and detect cyberattacks in real time. From this model, we built a real blockchain network to detect attacks using AI technology. This system includes a private Ethereum network with 3 blockchain full nodes named Ethereum Node 1, 2, 3, and 3 servers. The servers are performed as IoT gateways to collect data such as temperature, humidity, light, and fire alarm from the IoT network, and then convert them into transactions. After receiving these transactions, the blockchain full nodes will mine and then put them into blocks in the chain. We also use an attacked server to perform different kinds of cyberattacks on this network based on which, we generate data and examine the proposed solution. This is the user display interface that can perform real-time monitoring of the situation of the private Ethereum network. We introduced the first cyberattack dataset in the blockchain network named BNAT, which is created from the real traffic attacks from our system. In this system, we perform 3 kinds of attacks named brute password, BP, DOS, and flooding of transaction, FOT. These attacks were happened many times in practice and caused serious damage to many systems. The blockchain network is decentralized, so we need to collect data from various nodes for a comprehensive view of decentralized attacks. Our data can be used for researching, studying, or practical scenarios. We also proposed a collaborative learning model that can be deployed in the blockchain network to effectively detect cyberattacks in the blockchain network. The main idea of the proposed learning model is to enable blockchain nodes to actively collect data, share the knowledge learned from its data, and then exchange the knowledge with other blockchain nodes in the network. In this way, not only we can leverage the knowledge from all the nodes in the network, but also, we do not need to gather all raw data for training at a centralized node like conventional centralized learning solutions. Such a framework can also avoid the risk of exposing local data's privacy as well as excessive network congestion. The simulation results show that after 1,000 iterations, the curves of accuracy converged for all models. Both our proposed collaborative learning and conventional centralized learning models provide the same accuracy in detecting cyberattacks in blockchain network at a high level of 97%. Moreover, we deployed our model on each of the Ethereum blockchain node to evaluate the ability of real-time attack detection. The experimental results show that our proposed model can accurately detect various types of attacks in real time in the blockchain network. We conducted experiments to measure the real-time processing capacity of our proposed system model. The results show that the real-time processing capacity of our proposed system model can reach 85,000 samples within 2 seconds. This is the result captured from the real-time monitoring system. Our proposed model can monitor the status of the network in real time to detect attacks as well as to raise alarm when observing an abnormal increase in attack signals such as flood of transactions attack, brute password attack, or denial of service attack. In these figures, the different types of attacks and the normal situation of the network are presented in various color lines. In a normal situation, the normal line will be high and the attack line is nearly zero. If an attack happens, the line of this attack will increase in real time. Thereby, in all the cases, we can observe that our proposed intrusion detection system can detect attacks effectively in a real-time manner.